Okay. So I probably fixed my microphone. Hopefully, last one was the first video, so it's kind of clipping. And I just noticed that after watching. Okay. So I'm gonna start outlining. I think like everything in a question like this. Oh, actually, I guess it would be variables. Okay. So the first thing I'm going to talk about for question 2 is print line. This isn't necessarily what the question is really asking, but I'm just going to go over it because it's pretty important. So if I go on a free UIL test so that I can't be smitten for copyright or anything like that, I have a real like official test from like 2 years ago out in front of me that I constantly reference, but I can't show it because it's like behind a paywall that I paid for. But like, so if I have this question right here, this is question 2. We'll see that like we have a little bit of code right here. Don't worry about what it's actually in right now. But like we just see that there's this code right here. That's not actually enough to make a program run. What you actually need is let me throw that in the trash. Okay, sorry. You need these 2 lines above it. So you don't need to worry about what this says. Only if you're gonna, I mean, you should know if you're gonna be doing UIL computer science because you want to code yourself to like just get better at programming, especially for the programming part. But like for the written test, I don't think you actually need to know this. Just like know that any code you see in these weird boxes, fudge, like right here, just know that it's like inside this right here. So like what I mean by that is if I do system.out.println, this is the command to tell the computer to print something. So if you've ever heard of the Hello World project, that's literally just this, where like you're just printing something to what's called the console, and the console just shows text that you want the computer to print. So what system.out.println basically is saying is like you're just telling the computer, hey, I want to print whatever in here. So it could be like a word, and if you're going to do a word, you surround it with these quotes. And if you just want to print a number, then you can just type a number. Kind of like this. Okay. So the reason I say that is sometimes in the code, you'll see like, let me bring up this. So sometimes you will see like the whole thing right here, system.out.println, and then you'll see like what we're going to be worrying about next. But on the test, like in the 2018 test, they used out.println because it's getting technical, but basically we assume that the system has been imported, the system thing we're referencing here has been imported into our program, so we actually don't need to specify this. You don't need to understand why for right now, but like I can demonstrate. So if we just do what's called oh shoot, I actually don't know where it is. Oh, it's kind of embarrassing. It's obviously not just this. Java.suite. Okay, sorry. I don't want to spend too much time on this, so I won't. But basically, we just import the system, so you don't have to type system here. But it could be like out.println. So just know that it's like valid. Okay, so that's really all I wanted to say about println. Just know that like when we put stuff inside of the parenthesis there, we're just telling the computer to print stuff out, because what the question will ask is like, what is the output of the code segment to the right? And by output, they mean like what text is going to show up in the console. Because that gets pretty important for like question number 3 and question number 4. Okay. So we're going to talk about operators. So a mathematical operator is like plus, minus stuff. So it's like these right here. So in Java, like we have, let's see, like 5 plus 3. This is addition. This is what's called the operator of addition. So this is what we use in Java to say to add 2 numbers. This is to multiply, is called the asterisk. So if you hold shift and then press 8 on your keyboard, you'll see this little star thing that's called an asterisk. That is what we use for multiplication. We have the subtraction, which is like just 5 minus 3. So it's really intuitive. It's just like math in real life. And then a little bit weird is like 5 divided by 3. We do this like fraction bar, which is like that key where the question mark is. That's like right next to the right shift key. If you hold shift and press it. And the way you can like think about this is like, this is a fraction, 5 divided by 3. And this is also written as like 5 divided by 3. And like, hey, look, it's right there. I don't know. As long as you just know this is division. There's another one that you may not be familiar with. I wasn't before programming. It's called modulus. So what modulus is, that squeaking is my chair, by the way. 5 modulus 3, we represent with the percent sign, which is if you hold shift and 5. What modulus means is it's literally just the remainder whenever you divide. So 5 divided by 3. Well, that's 1 because 3 goes into 5 one time. Multiply, subtract, and you get 2. And 3 cannot go into 2, so you have a remainder of 2. So this is written in math like 3R2? R2? I don't know if it's capital. It's been a long time since 2nd grade. But basically it's just the remainder. So 5 modulus 3 would be 2 because you have 2 left over. 10 modulus 4 would be 2 because like 4, 8, and then you have 2 left over. 6 modulus 3. 3 goes into 6 2 times. So 6, and it's like divisible, which means like it goes into it evenly. So there's nothing remaining. So this would be equal to 0. So there's a few more spicy cases with modulus, as we can see here in D, but we'll go to that later. So the next thing we need to worry about is what I call like just like whole numbers, which is kind of weird, but you'll understand. So if I, let's actually like code a little bit. So if I do like 8 plus 4, okay, this will output 12. That's cool. If I do 8 divided by 4, this should output 2, and it does. But what about like 8 divided by 3? Oh, sorry, I messed up. Man, my chair is squeaking. So if I do 8 divided by 3, you would think it would be like 2.66666. But we can see in the terminal, it's actually only 2. That's not that Java is a dumb language. It's just that for reasons that you'll understand more when you program, this is actually what you kind of want sometimes, is you only want the whole number. What we're doing is it knows the answer is 2.66, but it's just kind of ignoring the decimal, so it's cutting it off, and that's called truncating. So let's say what if I want to print out the decimal? How do I do that? Well, there's 2 ways. Actually, there's a lot of ways. One way you can do it is you can just add 0.0 or point whatever you want to one of these. And that's just telling Java that when I do this operation, I want my answer to include decimals. And then if both of them are just whole numbers, you're telling Java, I don't want my answer to include decimals. So 8.0 divided by 3. And now we can see that the answer is correct. Well, right here, don't worry about it. So we can see that the answer is correct. You can also do 8 divided by 3.0. And then if you run it, it's still going to be correct. Like that. So you can see that all you need to really do is whenever you do an operation between 2 numbers, as long as one of them has the 0.0, then the answer will come out with a decimal. And this is true even if it divides evenly. 8 divided by 2.0, that should be 4, but because we included the 4.0, it will print out as 4.0. And this is on Invitational A, you can see a question like this, where it's just 2 plus this. This is literally something you could see on Invitational A. This question, right here is really simple. It's just this is 3, that's x. Oh, we'll get into what this int stuff means later. But basically 3 is stored in x, and then 2 is stored in y, and then 3 is stored in x. And it's literally just do the math. What is print out? And that's quite simple. It's not E, by the way. So if we go back here, okay, that's a good question actually. So Java is a computer language. So when we do math normally, we follow PEMDAS. So this would be done first, and then we'd add 2 to our answer. But computers are kind of weird. So what if computers always are binary and stupid and stuff? So what if it just goes from left to right? I could see that. It does 2 plus 8 divided by 2.0, so that would be 10 divided by 2.0, which is 5. So the answer is either 5 or 6. Now which one is it? It's 6. So Java uses PEMDAS. So it will do the division first and then the addition afterwards. And there's a whole table. So we could search up Java order of operations. So there's honestly 90% of the stuff you'll see here doesn't make sense. You'll learn it as you go on. But you'll see that, oh wait. You see that multiplication is above addition. These don't mean addition, by the way, even though they have pluses and minuses and stuff. Just ignore it. I shouldn't have brought this up. I'm sorry. But it's Java does follow PEMDAS. That's basically it. So just know that that these, as long as you include a point something, then that will be included, like you will have a decimal in your answer. And if it divides evenly, then it will, or if you just do like 2 plus 2.0, then that will come out as 4.0. So like as long as the two operations involve this, then it will always kind of have a, it will, that part when it's evaluated will be evaluated and keep the decimal. So here's a better question. What is output when we do 2.0 plus 8 divided by 3? So we learned that when you divide two numbers that don't have the decimal, like 0.0 or something, then it will just cut it off. But what about this? We have this number, after we do this, we're adding 2.0, which has it. So are we going to reintroduce the numbers? No, we're not. The way we can think about this is that 8 divided by 3, according to Java, because we're not including the 0.0, will be, 2.666. So we can think of it, the division is 2.666, but Java will just say 2 because it will cut it off. And so you can think of it as like when you do an operation, the answer of that will replace what was there. Like what I just did. So like you have 8 divided by 3, now it's just 2 according to the program while it's evaluating it. And now we just do 2.0 plus 2, and this one has the 0.0, so the answer will be 4.0. And now basically it will print that out. So just keep that in mind. And that's really all it is in terms of the math. Well, actually, besides the spicy modulus. So we'll talk about spicy modulus. So modulus is fairly easy, I would say. Like 7 modulus 2 has a remainder of 1, because like 2, 4, 6, and then there's 1 left over, so it has a remainder of 1. 11 modulus 3 is 3, 6, 9. You have 2 left over, so it's 2. Okay, this is pretty easy. It's just the remainder. However, what's like negative 11 modulus 3? Like, how the remainder of a negative? Like, I wasn't really taught this in like 2nd grade because I didn't know negative numbers could exist. Probably, I wasn't going into debt in 2nd grade. Okay, so if we do negative 11 modulus 3, how do we evaluate this? If you're ever confused on a modulus question, I just say do the long division, and it will always clear it out. So like negative 11 modulus, so like negative 11 divided by 3. Cowboy on top of the horse. Cowboy goes inside the house. Horse goes on the outside, like this. Okay, if you ever forget. Okay, so negative 11. So how many times does 3 go into negative 11? Your first answer may be 3, but it's actually negative 3, and I'll show you why. So like if we do 3 times negative 3, that's negative 9. But remember, we subtract this, so it's actually positive 9 because of negative of a negative. So it's a negative 11 plus 9, which is negative 2. So this is actually negative 2. And the reason why this is negative right here is because like if you do negative 11 divided by 3 and you put 3 here, well, this is 9 and now it's minus 9, so you have negative 20. And then you have like 3 goes into negative 20, 6 times, and then you got 18, 38. You could get a weird number. I don't know. Actually, hold on. I shouldn't, but like I actually want to see. It would be negative 38, right? Negative 38, 3. Dang it, I thought it was going to be like 3.66, because this is technically negative 3.66. I thought it was going to be like this, but it wasn't. Okay. Sorry, side tangent. Oh, wait, actually. No, it wasn't. Yeah, okay. Sorry, this is besides the point. I'm sorry. But basically, like, just long divide. So, like, negative 17 modulus 2. What the heck is that? Oh, that's easy. Just long divide. 2 goes in negative 8 times. Negative 16. Negative a negative. Positive. Negative 1. Boop. Let's just verify it. So, like, negative 17 modulus 2. Modulus 2. Boom. Negative 1. So you may ask, like, if you're like a quick learner, you may think like, wow, this is really easy. And it really is. Like, I'm looking at a 2018 state test, and I can't say like what is in it because like, it's behind a paywall and I don't want to get killed. But like, there's like a modulus and addition and subtraction and multiplication. It's like, it's really easy. So just as long as you just like keep these tips in mind, then you're good. The other spicy modulus case is like, let's say we have like 3 modulus 5. So this number is smaller than this number. What the heck happens? what did I say? Whenever you're confused, long divide. 3 divided by 5. 5 goes into 3 0 times. 3. Oh, your remainder's 3. Oh, your answer's 3. Is this actually true? 3 modulus 5. Oh, it's true. 3 modulus 50. Oh, sorry, I got rid of a parenthesis. My bad. 3 modulus 50. What's the answer? Oh, 3. 3 modulus like 500 million. What's the answer? Oh, it's 3. Okay. Yeah, so if you can pick up on it, a rule of thumb, I don't want you to memorize it. I mean, you can if you want. I memorized it. Like, if you just have a smaller number modulus a larger number, then the answer is just your smaller number. But just remember, whenever you're in doubt, just long divide, and then you should be able to figure it out through there. Okay. So this. Okay. So we're going to go over variables real quick because they're really important in programming. And sometimes you'll see, so instead of just like having out.println and then some like operations, you'll have like this right here where it's like this thing called int and then like x and then equal. Is really weird. So what's going on? Well, basically, like, it's useful in programming to like store a number and then be able to use that number later on. So basically the way we do that is you can think of like a variable, which is what these are called, as like a box, and you just like put a number in. So we're gonna put like 3 in, and then like 5 years go by and we're like, oh, I need this value again. So you just like yeet it out of there and then you just use it for whatever. So that's what a variable is. And the way we define that is it's called, like, the way I do it is data type and then the name equals thing. Data type name equals thing. So what I mean by that is you're going to have a data type that you type first, and this is just saying what kind of thing you're going to store inside your variable or box. You're going to put a name on the box, so it's really easy to recall, to just basically reference the number later and get the number back. And then this equals thing just says, hey, we're going to put a value inside the box. It's the assignment operator. And then the thing is just whatever you're trying to store. And then we have a semicolon because that's just how Java do. So like, for our example, the most common data type is called int. Int just stands for integer. I probably shouldn't do this. This is the symbol for integer, by the way. So integer, which is just a whole number. So this is just saying we're going to store some whole number. So like 5, 6, -5, 0, just like any whole number. The name we can put as whatever. So I'll just do like name x. So it's just like something that we can reference later. And we'll see in the example program. Sorry about Discord. Equals, and then thing. So whatever value. So you could do like 9, and then you just put the semicolon. Or it could be -1, or 0, or 10, or 100 million, or 200 billion. Just kidding. That's too big for the box. I'm not even kidding. So there's like a few more that I'll introduce. The main other one you have to know for this question is double. So we'll do double y equals like 3.0 or 3.1. So you may be able to infer double stores both whole numbers and decimals. So double is able to store 3.1, whereas integer cannot. Now let's say like we did int x equals 3.1. Is it going to be like when we print line where like where it will just ignore it? Well, let's type it out. Int x equals 3.1. Uh-oh. You can see like an underline here, like kind of in a word check or a spelling check. And an IDE, which is like where we program, that basically means you screwed up while typing code. So this is saying like type mismatch cannot convert from double to int. What that means is like this number right here, we could call it double, because it basically is like a decimal number, double decimal maybe. And we're trying to store it inside a box that only accepts whole numbers. So there's some problem here. So like if we look at our options, it says change type x to double, where basically instead of storing it in an integer box, we store it in a double box, which makes sense. But what's the other thing we see? It's add cast to int. So casting just means we change the number we're evaluating so that it works with whatever we're trying to change it into. That's kind of confusing. So we can kind of